Module 1, Lesson 29, Solving Percent Problems. Learning target, as has been the case with all of the lessons with percents. The percent learning targets are mixed in with all of the rates and the ratios because percents are a per 100, a rate per 100, and a ratio, a part-to-whole ratio of 2:100. And of course, we do a lot of scaling up and down to help us work with these percent problems. I can statements. I can find a percent of a given quantity. I can find the whole when I am given a percent and the part the percent represents. So the same I can statements we've seen in the last few lessons. Today is an exploratory challenge. We are going to try and make a generalization, which means we're going to try and come up with something kind of like a rule that we can follow. And we have two different situations that we are looking at that we are going to test out and see if these rules are true. And these rules are made as claims. And so maybe a classmate walks up to you and says, hey, I have come up with the coolest thing here. To find 10% of a number, all I have to do is move the decimal to the left once. And you're like, oh, that's pretty cool. And the question becomes, how can we make sure that that is true every single time? So we need to go through some activities here, and we need to come up with some models that we can apply to every single problem that will show whether or not this is true or false. Now, false is pretty easy. All you have to find is one example that it doesn't work for, and you've proven the statement is false. The claim is false. Proving it's true is a little bit more complicated. Some people would say, well, you just have to try it on a whole bunch of problems and see if it works. To prove that a claim is true, we have to come up with a general model that could be applied to any problem. So as we work our way through this activity, you'll notice right here that we are using a model to solve the problems. And what we'd like to do is be able to say, I can use this model for any problem and prove whether or not this claim is true. So before we start, need to make a prediction. Do you think the claim is true or false? And so this would be where you would want to pause the video and you'd want to think about this claim here and decide what you think. I am going to state that I believe the claim is true. And my reason for the claim being true is because 10 hundredths is 10%. And if I scale that down, I know that that is 1/10. And I know that in the base 10 system, the ones, the tens, the hundreds, that when I move the decimal to the left, that is the same as dividing by 10, which is the same as multiplying by 1/10. But now I need to come up with some models that actually show this happening. All right, so 10% of 300, and I'm going to use a lot of double number line today. I find that they make a fantastic model for working with percents, and if you've looked at some of my other videos, you know that I really like the double number line for percents. Well, I've got 100% out here, and I know that that is equal to 300. This is a whole. And I know that I am looking for 10%, and that that is going to be equal to a part. And so I'm going to count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And of course, I always get the size of my sections wrong, but it's important that I just understand that they're equal even if they don't look equal. So I have taken 100% and I have divided it into 10 pieces. And that means the 300 has been divided into 10, which means that I'm going to count by 30s, because 300 divided by 10 is 30. 30 times 10 equals 300. 60, 90, 120, 150, 180, 210, 240, 270, and then 300. And I found that 10% of 300 is 30. Okay, that's great. Now, the claim is that all I need to do is take the number 300, move the decimal one place to the left, and I have 10%. And it worked on this problem. I moved the decimal one place to the left, and I got 30. So here I have an example that I have set up with a model. And now the question is, can I use this same model over and over again to find 10%, and does it always work? So let's take a look at another problem. 10% of 80. All right, here's my double number line. And I know I've got 100%, and I know that 80 is equal to the 100%. I know that I am looking for 10%, and so I'm going to have 20, 30, 40, 50, 60, 70, 80, 90. So I've counted off by my tens, 20, 30, 40, 50, 60, 70, 80, and 90. And once again, just like on the last problem, that means that my whole has been divided by 10. 80 divided by 10 is 8. 8, 16, 24, 32, 40, 48, 56, 64, and 72. And once again, 10% is equal to 8. And if I have 80, and I move the decimal place one to the left, 8 is equal to 8. So the 10% is equal to 8. I've moved the decimal one place to the left. My model is still working, and I hope right now you're looking and saying, hey, what's happening in this model every time we do this is we are dividing the whole by 10. 10% is 1/10 of 100. So I take the whole, I divide it by 10, and I find 10%. Let's look at another one. 10% of 64. All right, I've got 100%. I've got 64. I've got my 10%. I'm going to count off by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. And once again, the 64 is going to be divided by 10. 64 divided by 10. Well, let's see here. I've got 6 times 10 is 60. And I've got 6 and 4/10. 6 and 4/10. We had 64. Take the decimal, move it one place to the left. 6 and 4/10. They are equal. So even on this problem, where in the ones place I had something other than a 0, it still worked. I was still able to take and move the decimal one place to the left. You'll notice on the first two problems in the ones place, it had a 0 each time. Well, now we've tried it with a problem that doesn't have a 0 in the ones place, and we still found 10% by moving one place to the left. And I'm going to say it again. I hope that you can see in here in the double number line, what we're doing is we are taking a whole and we're dividing it by 10. 10% of 5. Now we have only a single digit number. So it's not like we have a 1 in the tens place in some larger number, or that we even have a ones and a 10, like on the last problem. Now we just have a ones place. Is that still going to get us 10% when we move the decimal to the left? So I know I've got my 100%, and I know that's equal to 5, and here's my 10%, and I'm going to divide it into 10 pieces, 10, 20, 30, 40, 50, 60, 70, 80, 90, and now I need to take this 5, and I need to divide it by 10. And I have found that 10% is equal to 5/10. I started with 5. If the decimal moves one place to the left, they are equal. So this has worked now with numbers that have zeros in the ones place. It has worked with numbers that have something other than 0 in the ones place. And it's worked with single-digit numbers. With numbers in the hundreds, it's worked with numbers in the tens, it's worked with numbers in the ones. So now I'm going to test this out. Before I even start, 10% of 48, I'm going to say move the decimal, and I'm going to say it's 4 8/10. And then I'm going to use the double number line here to just prove and double check. And once again, notice the double number line is set up the same every single time. The only thing that is changing is the numbers on the top here. So here we have 48 as our whole, and we're asking for the part 10, 20, 30, 40, 50, 60, 70, 80, 90. 48 divided by 10. 4 times 10 is 40. Subtract, we've got 8. I can add a decimal so I can bring down another 0. Make sure my decimal moves up. 8 times 10 is 80. And once again, it has worked. This model is working every single time. I think at this point it's pretty safe to say that we have a valid generalization. This is working every single time. I have a model that can be applied to any situation, and it's working. 10% of 6 is 6/10. And to kind of move this video along, I'm not going to draw the model, but you would want to make sure you drew the model and understood what's happening. More importantly, I hope that you're starting to make some connection here that 10% is equal to 10/100ths, which is equal to 1/10. And in the base 10 system, when we move from tens to ones, we're dividing by 10. When we move from hundreds to tens, we're dividing by 10. So when we want 1/10 of something, the decimal is going to move one place to the left. That's a 1/10 as that decimal moves left. All right, Gary read 34 pages. What percent did he read? Well, if this is 10%, 340, 10% should be 34. Then if this is 10%, I should be able to move the decimal to the right to find the total. So we're going to take our model and we're now going to look at it a different direction. I've got 100%. I know that the total is 340, and I know that I have 34. Is that 10%? If I take the decimal and move it one place to the right, do I get 340, and is that 10%? Well, I would take this right here, 334. I would multiply it times 10 to get 340. And take 100 and I would divide it by 10 and I would get 10%. He read 10%. So notice that this works both ways. If this is 10%, I can multiply it times 10 and get the 340-page book. 16 pages of his book. If this is 10%, what we just showed on the last problem, if it's 10%, I will scale it up. I will multiply times 10 and get 160. which is equal to 100%, which if I divide by 10, brings me back to 10%. So what conclusion can be made about the claim? Well, this is a true claim. Yes, it's true. And I've explained it twice before, but 10% is equal to 10 hundredths, which is equal to 1/10. And because we have a base 10 system, everything's in groups of tens. Ones, tens, hundreds. If we want 1/10 of something, all we have to do is move the decimal one place to the left. That is the effect of dividing by 10. So 1/10 is equal to dividing by 10. So finding 10% is really easy. Now we can extend this and say that finding 1% is 1/100th. And to find 1/100th, we move the decimal twice. So if I've got 200, 1/100th of it is 2. So it's really nice to work in this base 10 system where everything is built off of tens. All right, different claim. If an item is already on sale, and then there is another discount taken off the new price, this is the same as taking the sum of the two discounts off the original price. So what they're saying here is there's something on sale for like $100, and they take off 10%. And then they say they take off another 10%. So it's $100. We take off 10%, it's 90. And then we're going to take off another 10%. And that would be the same as if I just add these two together and just take off 20%. Now, I think this sounds really nice. I think this sounds really easy. I just add these 2% off and subtract it from the original price, and I think everything's great. So I'm going to say that I think it's true because it sounds nice and easy and it makes sense. If I just add these together and subtract them, it'll be okay. For example, if I were doing 100 and I was taking away 5 and I was taking away 6, I'd get 95 minus 6 and I would get 89. And if I add the 5 and the 6 together, 100 minus 11, I still get 89. So I totally think that this is going to work because I can do it with subtraction. I can add the 5 and the 6 together and then subtract the 11, or I can take off the 5 and then take off the 6, and I'll still get the same answer. So let's test it out here. Sam purchased 3 games for $140 after a discount of 30%. What was the original price? Okay, so do a little thinking here. And we've got, come back here. There we go. So I know that I've got the 100%, and I'm trying to find out what that is. And I know that there was a discount of 30%. Purchased 3 games for $140 after a discount of 30%. So $140 is equal to 70%. Because this 30% here represents the discount. I don't know the dollar amount of the discount. I just know the price after the discount. So that's 70%, and I know that that was $140, and I'd like to know what the total was. And I'm going to break this into tens because 70 and 100 are both divisible by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. And I see that the 140 has been divided into 1, 2, 3, 4, 5, 6, 7 parts, and 140 divided by 7 is 20. 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. So I have found that the original price was $200. So I'm going to stash that away up here. I know that the discount amount was $60. I'll stash that away up here. All right, so let's see where I need to go now. So if Sam had used a 20% off coupon and opened a frequent shopper discount membership to save 10%, would the games still have a total of $140? So now they're saying I need to take off 20% and get a new price, and then take off 10%. Now my claim is that I should just be able to add the 20 and 10 together and actually just get 30% off. But now we're actually going to test it. So this is a two-step problem. I need to take off 20%, and then I need to take off 10% more. So I know that my total was $200, and that was 100%, and I need to take off 20%. Now taking off 20%, well that's double taking off 10%. So I'm going to use that claim we just came up with about moving, and I'm going to take the 200 and I'm going to say 10% is $20, and 20% is double 10%. So I'm going to multiply it by 2. So 10% is 20. Multiply it times 2 to get 20, and I'm going to take off $40. So I've got 80% of the price, and I'm going to take off 40 and have $160. So here I've taken off the 20% discount. So I've used his 20% coupon, and now I'm going to take off his $16 for his frequent shopper discount. So I need to, 10%. So I've got $160, and I want to take off 10%, so I'll move the decimal one place to the left. So I've got 160, and I'm going to take off 16. And I'm going to find out that when he takes off another 10%, he's now at 70% of the price. Well, it's not 70% of the price, though. Got to be careful there. So I'm going to take off another $16. So this right here is the 10% discount, which is $16, and I'm going to find out that he would have paid $144. Now, that's different than the $140. So it looks like my claim was wrong. I can't add this 20% here and this 10% here and say that that's the same as 30% off. Because I found that 30% was taking $60 off. But I haven't taken $60 off. I have taken off 40, and I have taken off 16. I've only taken $56 off. So do I agree with the claim? No. My prediction was wrong. I can't just add the percents together and take them off. Now, there is, of course, an explanation for why this doesn't work. When you take the original 20% off, you're taking it off the 200. And then when you're taking the 10% off, you're taking it off 160. When you take 30% all at once, you're taking it all off of the 200. You're not taking it off the 200 plus the 160. Well, and the 160. Not plus, and the 160. So the full 30% is coming off of the 200. But when we do it in 2 steps, when we take 20% and then we take 10% more, we're starting with the 200 for the first 20%, but then we are finding 10% of the 160. So no, this doesn't work. And you could try this out with any problem that has multi-step discounts. You could take off, well, let's do it out of 100. So something is $100, and I'm going to use 100 because it fits very nicely with our 100%. And if I take 50% off, then I find that it is $50. So 50% of 100 is $50. There's the $50 discount. Well, if we do this in 2 steps, if we say, let's take off 20%, and then let's take off 30%. So here's my 100%, and I need to carve off 20%, which will leave me with 80. That'll leave me with $80. Whoop, $80. Eraser. That leaves me with $80. So this is the first step. This is 20% off. Now I've got $80 as my 100%. And off of that, I need to take 30%. So I need 30% of 80. So 10% is 8, using our claim earlier. So 10% would be equal to 8. And to take off 30, I'd multiply times 3, and I'd take off 24. And 80 minus 24 is 56. So I took off 20% of the 100, and I got 80. 80 is now the full amount, the 100%, and I have taken off 30% of it to get $56. So I have gone through 2 steps here of So on the first problem, it was all 1 step because it was 50% together. And now what we've done is 20% off of 100 is $80. And then we have done 30% of $80. 20% is $80. Oh, wow. Gone and dragged my screen there. See if I can get that back. There we go. Let me try and say that correctly. So I took off 20% of $100, which left me with 80. And then I took 30% of the 80, which left me with 70% of the 80. And the 30% of the 80 was the $16. So I'm taking off 20, and then I'm taking off 16. So I'm taking $36 off. No, 16. My goodness, it's not even Friday. That'd be a 24 there. Much better, much better. So 20% of the 100 is $20, which left me with $80. And then I needed 30% of the $80, which was $24, and I would take that off. And that left me with 70% of the $80, which left me with $56. Instead of the $50 that I had up above. So what I hope you're seeing here is this was all 1 step. When I did 2 separate percentages, this is the first step, this is a second step. It's a 2-step problem, and I can't combine them into 1 step. you might want to go ahead and play with that one a couple more times. All right, solving the problems. I use tape diagrams. And of course, in class, we'll have a discussion about different ways that you solve them and what models you like. So hopefully at this point, as we conclude Module 1, you are feeling very confident about percents, being able to find a percent of a given quantity, and finding the wholes. More importantly, now that we are through 29 lessons, hopefully you are feeling really good about your skills with ratios. Being able to make comparisons with and within wholes. And of course, we know comparisons are ratios. Hopefully we can write ratios that are part to part, part to whole, whole to part. Hopefully we are comfortable with the different language and symbols that we are using with ratios. Hopefully we are feeling really good about equivalent ratios, that we can reason about ratios and we can make predictions about what would happen if part of the ratio changes. This relationship of A to B, and if I multiply them both by 2, they're still equivalent. And we can scale up and we can scale down. And then, of course, the last learning target, unit rates. Hopefully you are feeling like you can apply what you know about ratios to rates, that you can find a per 1 or a per 5 or a per 100. You can scale things up and down. And when we say per 100, hopefully you are feeling comfortable with what you can do in percents. So this concludes Module 1, Lesson 29, and Module 1. Of course, all the lesson materials and videos are available. If there's anything you're struggling with, you can go back and double check it. Make sure you complete your problem set, and if you've got questions, ask your teacher.